let's have a look at question 12. So part A is just a partial fraction question. So let's do that quickly. So part A, 1 over v times 25 minus v, that's equal to some constant over v plus another constant over 25 minus v. So if we make them the same denominator, so the first one we need to times by 25 minus v, and then the second one we need to times by v. So then that would be the same denominator as the other side. So we have 1 is equal to a times by 25 minus v plus b times by v. So if we let v equal to 0, then we will have 1 is equal to 25 times by a. So a is equal to 1 over 25. And if we let v equal to 25, then 1 is equal to 25 minus 25 becomes 0. So just 25 times by b. So which means b is also 1 over 25. So therefore, 1 over v times 25 minus v should be equal to, since both a and b are 25, so just 1 over 25 in brackets 1 over v plus 1 over 25 minus v. Okay, and then part B. So the volume V microliters of plant cell T hours after the plant is watered in model by the differential equation dv over dt equal to 1 over 10v 25 minus v. Okay, the plant cell has an initial volume of 20 microliters. So we want to find, according to the model, the time taken in minutes for the volume of the plant cell to reach 24 microliters. Okay, in this case, so we want to find the volume of the plant cell to reach 24 microliters. So we definitely need to find what volume is, and then we can plug in to solve it. So we need to integrate it first. So we have dv over dt equal to 1 over 10 v times 25 minus v. Again, we can't integrate v with respect to t, so we need to move all the v to one side and all the other to the other side. So I will divide by v and then 25 minus v for both sides. That would be 1 over v times 25 minus v. And then I will times by dt for both sides. So that would be 1 over 10 dt. And then we integrate it for both sides. So then 1 over v 25 minus v is just same as 1 over 25, and then 1 over v plus 1 over 25 minus v dv is equal to integral 1 over 10 dt. And then now we can integrate it. So 1 over 25, we can just take it outside. And then integrate 1 over v, that's just ln v. And integrate 1 over 25 minus v. So because it's just a linear expression, so that would be just ln of 25 minus v divided by the coefficient of v, which is -1. So divide by -1. That's equal to 1 over 10t plus c. So simplify this, that would be ln v minus ln of 25 minus v, our times 25 for both sides. So 25 times by 1 over 10, that would be 5 over 2. And then c times 1 over 25 is just some other constant. Let me just use d to denote it. And then we can try to combine this two into one logarithm. So that would be ln of v over 25 minus v equal to 5 over 2t plus d. And it says the plant cell has an initial volume of 20 microliters. So that means when t equal to 0, v is equal to 20. So substitute in, that would be ln of 20 over 25 minus 20. So 25 minus 20 is just 5. So just ln 20 over 5, which is ln 4. And then that's equal to d. So d is just equal to ln 4. So we have the equation ln v over 25 minus v is equal to 5 over 2t plus ln 4. And they want us to find the time taken in minutes for the volume of plant cell to reach 24 microliters. So we can just let V equal to 24 now. So if V equal to 24, then that would be ln of 24 over 25 minus 24, which is 1. So just ln 24 equal to 5 over 2t plus ln 4. So minus ln 4 for both sides. ln 24 minus ln 4, that would be just ln 6. Because minus 2 logarithm with the same base, you can just divide the numbers. So 24 divided by 4 is 6. So then t has to be equal to times 2 divided by 5, so 2 over 5 ln 6. And if we want to change that into decimal, so 2 over 5 times by ln 6, that's equal to 0.7167. And then be careful with the units. T means, the units for t is hours, so it'd be 0.7167 hours. And they want us to leave in minutes in part B. So times by 60, that would be 43.00. So just 43 minutes. All right, that would be the answer for part B. And then for part C, it's a show that question. So basically, we want to rearrange the volume into that form, okay? So look, we just continue from what we got before. So before we already have ln v over 25 minus v is equal to 5 over 2t plus ln 4. So they just want us to write in that form. So I will just continue from here. So if we change that into the exponential form, then that would be v over 25 minus v equal to e to the power of 5 over 2t plus ln 4, which is same as e to the power of 5 over 2t times by e to the power ln 4, which is e ln 4 just 4, which is 4 e to the power of 5 over 2t. And now times the denominator for both sides. So that would be 4 e to the power of 5 over 2t times by 25 minus v, which expanding out would be 100 e to the power of 5 over 2t minus 4 e to the power of 5 over 2t times v. And then once we have that, we can rearrange it, move all the v to one side. So v plus 4 e to the power of 5 over 2t times v equal to 100 e to the power of 5 over 2t. And then factorize out v, that would be 1 plus 4 e to the power of 5 over 2t equal to 100 e to the power of 5 over 2t. So then v is just equal to 100 e to the power of 5 over 2t over 1 plus 4 e to the power of 5 over 2t. And they only want a constant on top, so we need to find a way to cancel that. So we just divide by e to the power of 5 over 2t for both top and bottom. So if we divide e to the power of 5 over 2t for top and bottom, meaning we need to divide for each one of them. So 100 e to the power of 5 over 2t divided by e to the power of 5 over 2t is just 100 left. And then 1 divided by e to the power of 5 over 2t, that will become e to the power of negative 5 over 2t. Because 1 over means reciprocal, which means there's the power of negative 1. So it becomes e to the power of negative 5 over 2t. And then 4 e to the power of 5 over 2t divided by e to the power of 5 over 2t, there's just 4 left. So in this case, we will have a is 100, b is equal to 4, and then k is just 5 over 2, which is what they want. Okay, and then part D. So the model predicts that there's an upper limit, L microliters on the volume of the plant cell, and we want to find the value of L. We want to find the upper limit. So we already have V equal to 100 over e to the power negative 5 over 2t plus 4. So basically what they want us to work it out is just if t go to infinity, what's V equal to? So if t goes into infinity, so that means e to the power negative 5 over 2t will become 0. Because to sketch this one out, we know e to the power negative, so if it's a negative power, it has to be goes down. So if t keep increasing, eventually e to the power negative 5 over 2t will become 0. So then V is just equal to 100 over 0 plus 4 is just 4. So divide by 4 is 25. So then that would be the upper limit. Let's have a look at question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water. So the water starts to leak from a small hole at a point L in the side of the tank. So, which is point L here. Okay. While the tank is leaking, the depths h meters of the water in the tank is modeled by the differential equation dH over dt equal to negative 0.12 e to the power negative 0.12 t. So where t hours is the time after the leak starts. So be careful with all the units. So t is in hours and h is in meters. And then using the model, A show that h equal to a e to the power negative 0.2 t plus b, where a, b are constants to be found. Okay, so for part A, we just have to integrate dH over dt equal to negative 0.12 e to the power negative 0.2 t. So for this one, we don't have to use separation of variable because the expression on the right-hand side is just in terms of t. So there's no h in it. So we don't need to do separation of variable. We just have to integrate straight away. So h is just the integral of negative 0.12 e to the power negative 0.2 t dt. So that means h is equal to negative 0.12 is the coefficient, stay the same. And then since this is just a linear expression, so just e to the power negative 0.2 t, and then divide by the coefficient of t, which is negative 0.2 plus c. So simplify that, h equal to negative over negative cancel out, and then 0.12 divided by 0.2 is equal to 3 over 5. So h equal to 3 over 5 e to the power negative 0.2 t plus c. And now we need to find out the value of C. It says initially the tank is full of water. So that means when T equal to 0, so the cylindrical tank of a height 1.5 meters. So if it's full of water, that means the height of the water should be 1.5 meters. So H equal to 1.5. So then substitute in h equal to 1.5 and then t equal to 0. So that would be 1.5 equal to 3 over 5. And then e to the power 0 is just 1 plus c. So c is just equal to 1.5 minus 3 over 5, which is equal to 0.9. So then h equal to 3 over 5, which is 0.6. Let me just change it all into decimal. So 0.6 e to the power negative 0.2 t, and then plus c, which is 0.9. Then that'll be the final answer for part A. It's only 3 marks. Okay, part B. Find the time taken for the depth of water to decrease to 1.2 meter. Give your answer in hours and minutes to the nearest minute. So for part B, we want to work out time when t time, which is t. So when the height become 1.2 meter. So we just let h equal to 1.2. So 1.2 equal to 0.6 e to the power negative 0.2 t plus 0.9. So minus 0.9 for both sides, that would be 0.3 equal to 0.6 e to the power negative 0.2 t. And then divide by 0.6. So 0.3 divided by 0.6 is just equal to 1/2. So 1/2 equal to e to the power negative 0.2 t. So that means negative 0.2 t is just equal to ln of 1/2. So, and then 0.2 t should be the same as ln 2 because ln 1/2 is negative of ln 2. And then, so t is just equal to, so 5 ln 2. So because divide by 0.2, 1 over 0.2 is equal to 5. So 5 times by ln 2, put in the calculator, we have t is equal to 3.46573, and then the units would be hours. but be careful about what they're asking you. So give you answer in hours and minutes to the nearest minute. So then that should be 3 hours. And then we need to change 0.46573 hours into minutes. So it comes by 60 for 0.46573. So that'll be 27.94. And they want to the nearest minute. So 27.94 is just 28 minutes. So then that will be the final answer for part B. So that's another 3 marks. And then part C, in the long term, the water level in the tank falls to the same height as the hole. So part C, find according to the model, the height of the hole from the bottom of the tank. So basically, it's just asking you what's the limiting height. So if we let t goes into infinity, so that means either part of negative 0.2t will go to 0. Because either part negative 0.2t will goes something like this, the diagram. So as t get bigger, it'll get smaller and smaller, eventually turns to 0. So which means h should turns into 0.6 times 0 just 0. So it just plus 0.9 is just 0.9. So that means the height of the hole from the bottom of the tank should be 0.9 meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.